Hello everyone. In this video we will learn about the concept behind the lab number 4, which deals with energy and specific heat, and as well as we will learn about how to complete the lab report. When you log into your LabFlow account, you will go to experiment number 4. The first tab will give you the PDF file of procedure and the theory behind it, and then you can watch the calculation video in tab number 2, but I believe this video does not go into too much detail, so therefore I'm creating this video to explain all the calculations better. And as you already know, that pre-lab is here and the lab report is here. So let's first open the PDF file and go over the procedure. So if you open the PDF file, let me open it in a new tab. Okay. So you can read the procedure. I'll explain briefly what is the meaning of specific heat, and then we'll mainly go over the calculation part of this lab. In this experiment, we will use a technique called calorie metering. Now, calorie metering is a process for measuring heat transfer. And with the help of calorie meter, we will determine how much energy is stored in a food item. So in other words, we will measure the amount of calories which are stored in food items. So that's part B of this experiment. In part A of this experiment, we will determine a property of a metal which is known as specific heat, again using calorie meter. Now, what is specific heat? Now, specific heat is capacity to absorb heat of any object. Some objects absorb heat quickly and some objects absorb heat relatively slowly. The example is maybe metal as well and plastic. If we have a piece of metal in the sun and a piece of plastic in the same condition outside sitting in the sun, we will see that after some time piece of metal will be much more hotter as compared to piece of plastic. That's because of specific heat. Metals have high capacity to absorb heat, and when they absorb heat, the temperature of object goes up. Now, the formula to calculate specific heat is given by amount of heat absorbed divided by the mass of the object multiplied by delta T. Now, what is delta T? Delta T is change in temperature. Before absorbing the heat, the object will be at low temperature. So after it absorbs the heat, then the object will become at high temperature. So this difference in temperature is delta T. All objects have a specific value of specific heat, or in other words, all objects have a unique specific heat value. It's like fingerprint, kind of. So if we know specific heat, we can identify that object or that metal. Specific heat values of some metals are given in this table. So if we have unknown metals, so imagine that we have a piece of a metal and we don't know what is this metal, unknown. And somehow if we measure its specific heat, and its specific heat comes out to be 0.39 joules per gram per degree Celsius, then I can compare my value with the table, and only metal which has 0.39 specific heat in joules is copper, and then I can identify, oh, my unknown metal is copper. And this is the first part of our experiment. In the first part, we will given an unknown piece of metal, and first we will determine the specific heat of that metal. Then we will compare that specific heat value with this table, and we will identify what is the metal. Your metal will be one of these four. It may be either iron, copper, aluminum, or lead. So your end value will match with one of these four metals, and then you will figure out what that metal is. I'll go over the procedure briefly as well as the calculation part. The second part of this experiment is we will measure the amount of calories stored in a food item. The principal idea behind it is still the same, and we will again apply the formula of specific heat, which is equals to heat absorbed divided by mass multiplied by delta T, and we will calculate the amount of calories stored in a food item. So let's go over the procedure as well as calculations. The only formula which we will use in this experiment is of specific heat. So specific heat is equals to amount of heat absorbed divided by mass of any object, and this mass must be in grams, multiplied by delta T, and delta T must be in the units of degree Celsius. And amount of heat absorbed can be either in calories or it can be in joules. So this will be the formula which we will use in this experiment. So let's go over how we're gonna conduct part A. So in part A, we will be given an unknown metal. So imagine this is an unknown metal. So first we need to do is we need to weigh it, and we need to note down the mass of metal. And after you note down the mass of the metal, what we will do is we will take a container. In that container we will take some water, and we will heat the water. We will let this water boil. Once the water boils, we will drop this metal inside the hot water or boiling water. So make sure metal is all the way inside the boiling water. So the purpose here is we need to heat up the metal. We cannot heat the metal up directly on the flame, because then we will not know what is the temperature of the metal. But we will be able to determine the temperature of water by using any thermometer. So we will insert a thermometer, and we can note down the temperature of boiling water. Now temperature of boiling water will be 100 or close to 100, because that's where water boils. So if water is 100, this metal will also be at the same temperature. So now we have hot metal, and temperature of metal will be same as temperature of water. So this is the important concept. We cannot measure the temperature of metal directly. We will measure the temperature of boiling water, but the temperature of metal will be same as temperature of water. So that's step number one. So in step 1, we just weighed the unknown metal and we heated it up. That's it. In step number 2, we will make our own calorie meter. So calorie meter is just a device in which heat stays inside. So in this case, it's just a coffee cup, a styrofoam cup. So it's an insulated cup, so the heat stays inside. In this coffee cup, we will take, so first we will weigh the empty cup. And then in the empty cup, we will add some water. This water is 50 to 100 ml, whatever amount, it doesn't matter. So anywhere between 50 to 100. And after adding water, weigh again. So now it's cup plus water. So we have empty cup mass as well as cup plus water. So from there we can calculate the mass of water in cup. If we want to, we will subtract the empty cup mass from the combined mass, so we can calculate the mass of the water. After we note down the mass of the water, then we'll take the same cup, and inside the cup we have water, and we will put a lid on it, and lid has a hole in it, and we will insert thermometer in it, and we will measure temperature of water in cup. So this is temperature of water in cup. This will be at room temperature. Once you measure the temperature of water in the cup, then what we will do is we will take the hot metal from step number 1, and then we will drop this metal in the cup. And once you drop the metal in the cup, the temperature of water inside the cup will go up. It will heat up. And what we will do is we will monitor the temperature. We will monitor the temperature, and once it goes all the way up and it stops moving any further, we will note down the temperature. So this temperature is called T2, and the first one is called T1. So T1 is the low temperature and T2 is the high temperature. Why T2 will be high temperature? Because hot metal transferred its heat to the temperature. So metal transferred the heat, so metal will go down in temperature, and water will go up in temperature. Once you note down the T1 of coffee cup and T2 of coffee cup, our experiment is over. Next is just calculations. Now, before I go to the calculation part, couple of things I would like to mention here is that in this experiment we heated up the metal, so the starting temperature of metal will be high, so it will be approximately 100 something. So this is hot metal. Now in the coffee cup, the water temperature will be low. After we drop the hot metal in it, temperature of water, so T2 is water temperature, it will be higher than before because metal transfer the heat, and the metal, it will be low, it will be at low temperature because it's lost its heat. So the metal heat has been transferred to water, so metal will be low, and metal temperature will also be same as T2 because that's where they equilibrate. So this was the experimental part. Now let's go over the calculation part. Okay, let's go to the lab report section. So when you log into your lab flow, and you need to scroll right and go to data and report submission, and let's click on the report. And because we are completing this experiment online, we need to choose yes here, and then we will click next. And you will see a message that if you are completing this report online, you will get a provisional data. So what does this mean is that remember when I talked about measure the temperature of water, temperature of metal, mass of water. Now because we are working remotely, we're not going to actually measure it, so that data will already be measured for you and you will be given those results. So click on the request provisional data and then say confirm. You will get data already measured for you. So for example, in this case, I got unknown metal identification number 1. When we measure the mass of metal, it's 18.48 grams. It's already measured. I don't have to do anything. Mass of the empty cup. So this one is empty cup. Its mass is 1.88. And mass of calorie meter and water. So calorie meter is just a cup. So let me expand it. So mass of calorie meter and water. So calorie meter is just a cup. The calorie meter cup is same as calorie meter. So it means water plus the cup together is 47.61 grams. There are 2 trials. I'm only gonna go over one trial. Temperature of boiling water bath. So this is the water bath where we heated up the metal. So it's, like I said, will be close to 100. So it's 100.43. Initial temperature of calorie meter water. So this is the water inside the cup. Starting temperature, that's 22.64. See, it's at low temperature. And final temperature of water plus metal. So this is the temperature when the hot metal was dropped in the water inside the calorie meter cup. So that's why temperature of water went up. So it went up from 22 all the way up to 28.99. So that's the first section. So these are the numbers needed for first section. And next part is the second section. We'll go over it in a while, so let's ignore these numbers. So let's go over the calculation part. Okay, so for calculation, so we need to identify the metal from the specific heat. It means we need to first find what is the specific heat, and then we need to compare the specific heat value to the table given in the PDF file and identify what the metal is. So these are the numbers which were given to us, and now we need to do calculations. Let me pull up the PDF file also. So the PDF files, the data analysis is given here. So let's have both of these files side by side. Okay, so first is mass of water. So this mass of water is the water inside the calorie meter cup. So calorie meter plus water is 47.61, and calorie meter alone empty is 1.88. So if I need to calculate the mass of water, so I need to subtract the empty cup mass from the combined mass. So the answer will be equals to, in my case, is 47.61 minus 1.88. So whatever the result is, that should come here. Don't leave it like that. Calculate the number and put that number there. Okay, so I'm not gonna calculate that number. So I'm just gonna say, imagine that number is A. So you calculate the number. Right now I'm just gonna put A here. Next is temperature change of water, and do not include the negative sign. Even if you get a negative sign, please do not include it. So temperature change, so this is the temperature change inside the calorie meter cup. So remember, before we dropped the hot metal, the temperature was 22.64, and after the hot metal was dropped, temperature went up to 28.99. So this change is the temperature change, and the formula is given. So this is the formula or equation which will work here. Okay, so delta T water is T water final minus T water initial. So in other words, 28.99 minus 22.64. Okay, you will get some value, so put that value here. So I'm gonna call this value to be B. Next is heat gained by water. Do not include the sign. So the equation or formula to calculate the heat gain is number 12. So this is the equation. So this equation goes here. So apply this equation. So it's equals to mass times delta T times specific heat of water. So mass of water is A, because we calculated it to be A. So multiplied by delta T of water. Delta T of water we just measured to be B, multiplied by specific heat of water. So if you read the PDF file, you will find that the specific heat of water is 1 calorie per gram degree Celsius. Don't include the unit, just include the value. So it's 1. So A is mass of water, B is temperature change times 1. So whatever value comes, that will be here. So let's call this C. Heat lost by metal. So heat gained by water. Where did water gain the heat from? Water gained the heat from the metal. So if water gained C amount of heat, so metal must have lost same amount of heat, because law is energy can neither be created nor destroyed, so it can be transferred. So if one object is gaining the heat, the other one is losing it. So heat lost by metal is heat gained by water. So this is the equation which goes here. So number 13 is the equation for this section. Finally, temperature change of metal. So temperature change of metal is this formula. So T metal final is same as the T water final. It equal to 28.99 minus the starting value of metal. So starting value of temperature of metal was the hot temperature, which is same as the boiling water temperature. So in my case is 100.43. So it will be 100. So 100.43. Like I said, do not include the negative sign, although if I do it, it's gonna give me a negative sign, but we're not gonna include the negative sign. So whatever the value comes, calculate it using your calculator and plug in the value here. So I'm just gonna call it D. Okay, so finally we calculate the specific heat of metal in calories. So specific heat of metal, this is the formula. Okay, so specific heat is equals to heat divided by mass times delta T metal. Okay, So heat we already calculated, heat loss by metal. So that's the heat. So it's equals to C divided by, in parenthesis, so what is C? C is the value which we calculated here. Okay, so that value divided by mass of metal. So mass of metal is given here. So in my case is 18.48. So C divided by 18.48 multiplied by delta T metal, and delta T metal I just calculated the value was D. So I'm just gonna, whatever the value of D is, so it's gonna be D here, close parentheses, and calculate this value. Don't leave it like that, just calculate this value. Whatever the answer comes, plug in that answer here. Imagine that in my case the answer comes out to be some value F. Let's say this comes out to be F. Finally we need to calculate specific heat of metal in joules. So if you want to calculate specific heat of metal in joules, all you need to do is you need to multiply whatever value you get in calories. In my case it was F. You multiply it with 4.18. So that will give you the value in joules. So this will give you some number. Okay, so that number, so note down that number. Once you note down that number, you go to your PDF file and then scroll up, go to the table on first page, and then compare this value with these numbers. If this, and then find the closest value. Imagine that I got value to be 0.9 here. So if I got 0.9, then the closest value is 0.92, and 92 matches with aluminum. So my unknown metal is aluminum. So identity of metal will be aluminum, and I am done for that part. The second part of this experiment deals with the calculation of calories stored in a food item. The experimentation is pretty simple. So what we do here is we take an empty soda cup, a can, and we note down the mass of this can, and then we add approximately 100 ml of water in it. So there is water inside, and we insert a thermometer and we note down the temperature of that water. And then we also note down the mass of water plus soda can. So we note down the empty soda can mass as well as the mass with water. And then what we do is we take our food item. That food item could be a chip, could be a peanut, or a cashew nut, or any food item which burns, or which gets ignition, or which can catch fire. And we put our food sample here, and then we light it up, we burn it. Once it burns, it releases all the heat, and that heat energy will get transferred to the water. So once the water absorbs the heat from the food sample, the temperature of water will go up. So once all the food item is burned, it means all the calories are transferred to the water, and then we note down the highest temperature of the water. And any leftover ashes are also collected, and we note down the mass of the leftover ashes also. But before burning, we note down the mass of starting food sample also. And once we do that, our experimentation step is done. Next part is calculation, and I'll go over the calculation now. Before I discuss the calculation step, remember the formula which we will use is exactly the same, the one which we used previously. This is the formula. Okay, so let's go over the calculations. So when you go back to your lab flow, you will get some data already given to you. So for example, the food sample which we analyzed was Doritos, so maybe one Dorito chip. Mass of empty can was calculated to be 12.62 grams. Mass of can plus water was 122.17 grams. Initial mass of food sample, so this is the mass of food sample before burning, so Dorito chip. So that mass of Dorito chip was 1.85 gram. Initial temperature of water, this is the temperature of water in the cup. It was measured to be 20.26. So this is the temperature before we burn the Dorito chip. And final mass of food sample, so this is the leftover ashes, because after you burn the food sample, some ashes or some material will be left over. So that leftover mass is 0.69. Final temperature of water, this is the temperature of water after it absorbed all the heat from the food sample. So in our case, it's 21.83 degrees Celsius. This data does not show any units, but remember, units are given here. So when we enter the data, we do not enter any units. Units are described here on left hand side. So these are all the values given to us. Now we need to use these values to calculate the calories stored in this food sample. So we will scroll down and we'll find the calculation part for the calories per mass of food. So again, we can the PDF file, we can open the calculation. Oh well, that's the calculation part anyway. Here, so first is mass of water. So mass of water can be calculated using the first two columns, first two rows here. So mass of can plus water is 122.17 and can alone is 12.68. So we can calculate the mass of water by subtracting. So 122.17 minus 12.62. So whatever value comes, you put that value here. So I'm not gonna calculate, so I'm just gonna call it MW. MW means mass of water. Or let's call it A. Temperature change of water. So temperature change of water means after absorbing the heat, how much was the change in temperature. So remember, before heating the temperature of water was 20.26, after heating is 21.83. so we can calculate the change in temperature by subtracting. So it will be 21.83 minus 20.26. You use your calculator and find the value, plug in that value. I'm not gonna do it here, I'm just explaining these calculations. So I'm gonna assume that this value comes out to be B. Okay, next is heat gained by water in calories. Do not include the negative sign. So the formula is this one. Excuse me. The formula to calculate the heat gain is this one. So in other words, in order to calculate the heat, we need to know the mass of water, which we already know. That's here. We need to know the delta T of water, which we already know, that's B, and then we need to multiply with 1.00. So it means heat gained by water will be equals to A multiplied by value B multiplied by 1.00. So whatever the answer comes, that answer needs to go here. Imagine this answer comes out to be C. So just put that C. So the value is in calories, so that's the unit, calories. Next is heat gained by water in kilocalorie. Kilo is 1000 And in order to calculate kilocalories, we need to, let me clean this up. Okay, in order to calculate kilocalories, this is the formula. We just need to divide the value by 1000, right? So in other words, so you take your value calculated in previous step, which is C, and divide by 1000. So C divided by 1000, that will give you the answer in kilocalories. So whatever the number is, I'm gonna call it D. And finally, heat lost by food. If water gained D amount of energy or kilocalories, so where did that come from? That came from the food. So if we are calculating heat lost by food in calories, that will be same as C. Okay. And if you are calculating in kilocalories, that will be same as D. So whatever value of D you find out, just plug in the same value here. And finally, mass of food burned. This is amount of food which was burned. So that can be calculated by subtracting the starting mass of food minus the leftover. So remember, our starting mass was 1.85. So this will be 1.85 minus the leftover mass, which was 0.69 in my case. So 1.85 minus 0.69, whatever answer comes, you plug in that value there. So imagine this answer is E. I'm just gonna call it E. And finally, we need to calculate the calories per gram of food, and the formula is given here: kilocalorie divided by mass of food. So in this case, we measured our kilocalories to be D and mass of food is E. So it means we need to divide D by the value E. So whatever number you get, that should be here. And with that, we conclude these calculations. The other analysis, this is same as what we kind of similar to dimensional analysis. So using the following nutritional label, answer the question. So this is the label. So first question is mass in 1 serving of fat. So we look at here. So in this we have 8 servings, right? So amount per serving. So for every 1 serving, we have total fat equals how many? 8 grams. So our answer here will be 8 grams. Calories in 1 serving. So in 1 serving, so that's the calories, 230. So 230. And similarly figure out the rest of the answers from this data label. If you have any other question, please feel free to contact me by email or see me in my office hours. Once you finish all of these sections, click submit, and then you are done.